lunch break, if that's okay. And I was going to briefly introduce the two presenters. We have two PhD students from Tatsumi University, and this time they don't come from the computer science department or anything like it, but they come from the School of Applied Languages and Intercultural Studies, so that's a very welcome addition to our proceedings, and a very important one too. The two are Midori and Tatsumi, who is studying under the supervision of Sharon O'Brien and Minako Hagen, who I believe are both here. And they work very closely together with Fred Hollywood in Semantic. Yanli is another student and who works together with Midori on the same project, I believe. And they're going to report on that project and the progress that they have made to date. And it's called Linguistic Comparison and Analysis of Statistical Post-Editing between Chinese and Japanese. So, two very, very important languages that people in Europe know usually very little about. So, thank you very much for coming and for preparing the preparations, the presentations, and please welcome Midori and Yanli to.
Statistical post-editing on Chinese and Japanese under the supervision of Sharon O'Brien and Minako Hagen. This study was supported by Semantic Ireland with the help of Fred Hollywood and Midori. I'm not good at French. Raw theory. Here's a simple outline of our presentation. I will briefly introduce the theoretical background, related works, and our experimental setting. And part 2 and part 3 are the main content of our study, which will be later explained in detail by Midori. And finally, we will come to the conclusion together, wrap up our findings, and point out the future work. Okay. Well, as Andy pointed out, machine translation is a facilitative application for localization. But one of these machine translation systems is rule-based machine translation, RBMT for short. There are 3 stages in this MT system: analysis, transfer, and generation. Analysis is a process to analyze a source text into its abstract, lexical, and structural representations, which will then be transferred or converted into its target language representation. At the generation stage, the final target text will be generated, mainly based on its own linguistic rules. Well, later, a new machine translation system, which is the state-of-the-art MT system explained by Andy, is statistical machine translation. SMT for short. There are 2 stages in this MT system: training and decoding. Well, training is a process to automatically learn the translation and language knowledge from parallel bilingual corpus. And decoding is a process to translate new sentences using the above learned knowledge. Well, there are both RBMT and SMT have their pros and cons. According to Simon, an effective way to combine these 2 MT systems is statistical post-editing. So what is statistical post-editing? First, what is post-editing? Post-editing is a process to manually correct the output of an MT system. Traditionally, post-editing is done by human post-editors, which is, of course, a tedious and time-consuming job. So, automatic post-editing using the help of a machine is proposed. Recently, with the advent of statistical machine translation, a new post-editing method, statistical post-editing, comes out. So, how does a statistical post-editing model work on a rule-based machine translation output? Now, first, let's see a simple flowchart RBMT. Given a source text you want to translate, a traditional RBMT will analyze, transfer, and generate the output of the target translation, that is output 1. Well, then of course, this output is not perfect, it's not error-free. Human post-editors will be needed to produce the final translation. This is especially important if you want the content to be localized. And after adding a statistical post-editing model, the translation process will go like this. First, an SMT will be trained on parallel bilingual corpus. Here, the raw RBMT output will be the source, and the corresponding reference, either human post-editing or human translation, will be served as the target. This SMT will be trained to learn how to translate this raw RBMT output into another, hopefully better translation. Well, certain translation and language model will be built after this training process. They are the core of our statistical post-editing model. So, if you want to translate another new text using this RBMT system, first it will give you the output, the raw RBMT output. And then this SPE model will be recruited to post-edit or translate this raw RBMT into another, again, hopefully better translation. This is output 2. Well, in most cases, this output is not perfect too, either. So human editors are still needed to produce the final output. Well, of course, this is a very general introduction to RBMT and SPE. For more information, please refer to the literature here. Well, our experiment, the experimental setting is like this. Given this SPE model, we use English as our source language, and we try to analyze the output of Chinese and Japanese, DH for Chinese and GE for Japanese. And the RBMT used is System, commercial and rule-based machine translation system. Well, most commercial RBMT systems provide customization options for their users. That is, for example, the user dictionary. So we also use the user dictionary of Symantec in our RBMT system. And for the training, for the SPE model, we use the Moses as our SMT tool, SPE model. Moses is an open resource, which is a statistical machine translation system. The reference is from Symantec, the translation memory given by Symantec. The statistics is like this. There are different units in Chinese and Japanese. And what we did is to analyze the output or compare the output 2 with output 1 to analyze the effect of this SPE model. We try to analyze what kind of modifications made on the raw RBMT by comparing output 2 with output 1. So first we did a pilot project by randomly selected 100 sentences for each language. Then we classified the modifications into different categories based on the study zero. The first category is on the distinction between content word and function word. The modifications have alteration, deletion, and addition. And the second category is on the changes of tense, voice, imperative, and formality. The last two categories, imperative and formality, are especially important in Japanese. By formality, we mean the politeness form of a word or a sentence. The third category is fixed expressions. For example, in general, such as, etc. The fourth is reordering. Any change of word order within a sentence is counted as a reordering category. And the the last one is modifications on use of punctuation. Well, we also define the three values based on the work of Duga on the modifications made by this SPE model. They are improvement, degradation, and equivalence. For detailed analysis of the results, I will hand over to Midori, who will explain in detail to you.
Now I will give some of the details of some of the findings from our evaluation. Each figure in this table shows the number of modifications we found in each of the 100 segments. And we counted those modifications on item-by-item basis rather than sentence-by-sentence basis. So one sentence can contain multiple modifications. Each time we found any modifications, we categorized it into the classification that we just described, and then decided if it resulted in improvement, degradation, or equivalent. Now, as you can see, certain types of changes occurred a lot while others didn't. And if you compare the numbers between the languages, you can see there are some similarities and differences. Now, I will start with some similarities we found in relation to our qualitative evaluation. The first similarity is the alteration of function words, which happened a lot to both languages. And for both languages, the number of improvements was over 5 times more than the number of degradations, which is a good sign. Now, I will give you some examples. A good example of this is the prepositions such as to, for, or with. Ability systems often have trouble selecting the most appropriate translation for those prepositions. And each example shows that the empty output, the empty output chose not incorrect but not quite appropriate translation, whereas SPE process changed into more appropriate translation of preposition, which contributed to make the sentence more fluent. The second similarity is the deletion of function words, which also happened a lot in both languages. And for both languages, the number of improvements are more than 10 times more than the number of degradations. A very good example of this is personal pronouns such as you and your, which are often omitted in the natural writing of Chinese and Japanese. LBMT tend to explicitly translate those personal pronouns, and during the SPE process, such unnecessary personal pronouns are being omitted to contribute to make the sentences more natural. The third similarity we'd like to point out is the punctuation, which also happened a lot. What happened a lot for Japanese is the conversion of the full stops. LBMT produced the standard Japanese full stops, which is okay for normal circumstances, but in certain circumstances, such as IT documentation, it is often preferred to use English full stop. So LBMT did it according to the standard rules, while SPE changed it according to the sentence-specific preference. In Chinese, in the case of Chinese, there are lots of unnecessary commas inserted in the sentences, which are successfully omitted during the SPE process. Now I'll move on to the differences we found. The first one is alteration of content words, which consists of the largest number of changes made on the whole thing. As for Chinese, the number of improvements is about 7 times more than degradation, while some of the examples. First, two examples are for Japanese. The first one is the example of improvement. The English source console command is supposed to be a noun phrase, but in RBMT output, the word command is translated as a verb to form a sentence. And during the speed process, it is converted to back into noun phrase, which helps the accuracy of the sentence. And the second example is the example of degradation. Both Japanese words are correct translation for the word number, but the first one is the sequence number, and the second one is the quantity. And in this case, RBMT translated correctly, but SB changed it into a wrong word. Nice try, but wrong. What happened a lot in Chinese text was a lot of English words remained untranslated during the RBMT process, and it was translated into appropriate Chinese words during the SB process. The second difference is the addition of function words, which happened over 30 times for Chinese text and only about 4 times for Japanese. The example of the addition of function words is that both are for Chinese, and the first one, SB added the word that indicates the tense, while the second one added the translation of preposition. Both contributed to produce more appropriate and correct sentences. The next difference we'd like to point out is that the modifications on forms of the imperatives, which happen none to Chinese text, but 10 times on Japanese text, which mostly resulted in improvements. What happened was, mostly, RBMT produced standard imperative endings, which is no problem in the normal circumstances, but in certain contexts, such as IT documentation instruction manuals, it is often preferred to translate imperative sentences as normal affirmative sentences. So RBMT translated the sentences according to the rules. SPE changed it into more appropriate sentence in a certain context. The next difference is the modification of fixed expression, which happened quite often for Chinese text compared to Japanese text. The example shows the translation of the word in general. RBMT produced correct translation, but not quite appropriate in certain contexts. So SB changed it into more appropriate expressions. There's a lot of going to. The last difference is the word phrase reordering, which happened more often to Chinese than Japanese. Here, the translation of the word then is moved to the front part to produce more appropriate however, I'd like to point out that this, not only this, but all the body reordering happened only in a very local region, only within a few words. And there has not been any long distance about reordering that affects the sentence structure itself. Those are the detailed explanation of the differences and similarities. But overall, there are 2 important findings here. The first one is the number of improvements for both languages are much more than the number of degradation. And the second finding evaluating the modifications on item by item basis, we were interested in the effects of SPE on sentence level in terms of fluency, adequacy, and possibility time. Fluency is defined as the well-formedness of the sentence according to the target language grammar. And adequacy means how much of the information in the source text is successfully conveyed in the target text. And the peak time means the time necessary to edit the output into the level of appropriate level for publishing purposes. So we used the same 100 segments, and we recruited 4 evaluators and presented source text and 2 output text, 2 target text, one from LPMG and one from SPE, and asked them to decide which have the better quality in terms of fluency, adequacy, and which output they think requires less post-editing time. So they were given 3 choices, either 1 or 2, or if they thought both have same level of quality, they are asked to put E. To avoid the biased view, we selected randomly 50 sentences and then changed the position of LBMT and SPE, so it worked as blind test. Fluency and adequacy are usually evaluated in a scaled manner, like 1 good English to 4 English, etc. So in this case, we only use the simplified version, choice between the 3. The main reason was, well, one is time restriction, but another reason is that in this project we are only interested in which is better, rather than the quality of individual sentences. And after we got the results, we tested the inter-evaluator agreement level, which is done by Kappa scores. Kappa scores is becoming increasingly popular to see the validity of the data for comparison, where multiple number of evaluators are involved to see the agreement between the evaluators. Kappa score is given as a value between 0 and 1, and anything from 0 to 0.2 is regarded as poor agreement, and 0.2 to 0.4 fair agreement, 0.4 to 0.6 moderate agreement, 0.6 to 0.8 substantial agreement, and over 0.8 is regarded as a perfect, almost perfect agreement. And this is the score for both languages. There is a noticeable difference between 2 languages. Anyways, both are over about fair agreement. For Chinese, it's around mid-range of fair agreement. So we concluded that both values are valid for comparison. And this is the result of the sentence level evaluation. Each figure shows the average number of the choices made by evaluators. And as these figures show, for Japanese, for all 3 criteria, fluency, adequacy, and read time, around 60% of the cases, evaluators chose SPE output over 80. And for Chinese, 40% of the cases are regarded as better quality in terms of fluency and adequacy, and 50% of the cases are regarded as better quality in terms of facility time. Interesting findings here was, first of all, we received a very brief report of this evaluation project from the evaluators, and they say both outputs are really bad. And they say both outputs sound very much like machine translate. But those figures speak out by itself. They are not shows much more often the output over MT, so I think this is a good sign. And another interesting thing is according to this result, it says Japanese have more improvements than Chinese, which in a way contradicts with another evaluation project we did. One of the explanations may be that the difference of the units of the evaluation. The first one was done on item by item basis, the second one sentence by sentence basis. So if certain sentences contain a lot of sentences, while others don't, there will be some discrepancy. Anyway, we don't have any conclusive answer to this matter in this pilot project, but it must be very interesting to further investigate into this matter, maybe with larger number of subjects, larger amount of documentation or different methodologies. So now I gave you a detailed explanation of our results, and Yanli will give you a short conclusion.
Based on our two analyses and evaluations, we come to the following conclusions. First, SBE generates more improvement than degradation. And as Midori pointed out, there are 3-fold for Japanese, while 6-fold for Chinese. And the second one is linguistic changes vary between Chinese and Japanese. And the third one is SBE changes are generally limited to word level. There are very little long-distance reordering or changes on sentence level occurred. And the final conclusion is SBE improves the influency, adequacy, and can shorten the post-editing time. And that's all for our findings. Thank you for your time. Questions?
Thank you very much. It was a challenging presentation, and you stuck with the time. It was very, very interesting to do. I shouldn't have said that, but it's important in our case, unfortunately. We can take a few questions because you did so well. Please.
It's very exciting. I have a question about your second evaluation. So you said that you measured post-editing times. So presumably you asked for the post-edit, right?
No, we asked the post-editors which output they think requires less time.
Oh, so they have to estimate.
We didn't
should they post-edit it? Which of the processes will take longer? So it's like how they take
decisions.
Okay. And the second clarification is, how does this feed back to the first evaluation that you made? Because you also made some qualitative judgments here as well, in terms of improvement, degradation, and so on. It seems more or less that somebody classified the sentences the same way. Right? Is there an agreement between the first and the second evaluation? I mean, it's not very clear to me.
Yes, there are lots of disagreement between the evaluators, so we did not see clear characteristics of the modification, the relation between the modification and sentence level improvement of evaluations.
Well, this is based on a constituent, more or less a constituent level. We did it by ourselves.
Okay, yeah. I mean, that's the question really. If there's any relation between the classification that you made and the classification of the other four people.
Other 4 human evaluators, and we didn't do any correlation test on these two.
Joseph?
I think it's really good work and very interesting work. So I really enjoyed your talk. I think your conclusions are valid. One thing where maybe one has to be a little bit careful is comparing the Japanese and the Chinese, because you have 2 different machine translation systems, rule-based systems in the first case. And so one of them might just be better than the other one. You have 2 different statistical machine translation systems. And for Chinese, for example, you have 3 times the training data that you have for Japanese. And I think these will all be factors in your overall results, and it might actually explain some of the discrepancies between this table and sort of like, where you at the end measure the sentence level analysis and improvement in post-editing time this shows.
I think there was more a comment than a question, something like Can we take Org's question too, and then you can answer to the two together?
So my question was, why do you think the inter-evaluator agreement was so much lower for Chinese and Japanese?
First of all, we found that Japanese evaluators returned quite similar results, whereas Chinese evaluators had different opinions. So we were interested in validity of the data for comparison.
So it's a people effect and not a language effect. So just more opinion.
We don't have the answer to that.
I'd like to put the thing back into its reference environment. It's an industrial study, and because I'm involved, you use everything you have. So we didn't even attempt to make sure that things were finely tuned here. What we wanted to do was to get a pilot study done to scope out what the area was like. Now, it seems to me that SPE looks as if it could be very useful, and it seemed to me like we should pour everything we had into the first pilot study and scope it out efficiently, and then open up the field for people to work in. So, you know, that's what I think is the big plus here.
And it's really nice to see that. And I think you can control some of the things that I mentioned earlier on. Like you could, for example, just train the Chinese system on a third of the data, and that would make it a little bit more similar to the Japanese. But what you don't have control over is the Sichuan versions, I guess, for Chinese and Japanese. But it's stuff like that. If you want to continue with your experiments.
The comparison is quite difficult.